Welcome everyone to today's Learn Live session where we're going to talk about getting started with prompt flow to develop large language model apps. My name is Mary Jo and I'm a senior content developer at Microsoft and I'm here today with Vale.
Hi, hello everyone. I'm Valentina and I'm a data and AI solution specialist in Italy. And today we are super excited to welcome you back to another episode of the Microsoft Learn AI Skills Challenge series. For those of you who are joining us for the first time, Microsoft AI Skills Challenge is a comprehensive skilling experience made of two main components. The first one is a self-learning gamified experience through a four tracks cloud skills challenge, including Microsoft Fabric, Azure OpenAI, Azure Machine Learning, and Azure AI Fundamentals. That lets you become eligible for a free exam voucher after the course. The second component, that is the one we are leading today, is a guided trainings delivered through the Learn Live show format by a global team of subject matter experts like us. and so today we are delivering the fifth part of a 9-episode series. And if you didn't follow the previous episodes, be sure to recover them at the link below. And also say hi to our amazing moderator that today will be handling the messages in the chat. And again, if you want to follow live the learning path that we will be covering today, feel free to scan this QR code in order to read and follow the topics that we will be covering today. Feel free to stay interacting during the conversation, ask questions, comments. We will do our best to address even live some questions that you will make, or either we will respond directly in the chat. So, what are the learning objectives for today? We know that with large language models, we entered a new era of application development. So, managing the life cycle of an application with large language models is something a bit different compared to the standard and traditional way of managing applications. So, we will understand the development of life cycle when creating large language model powered applications. We will then cover how to build the backend logic of an LLM-powered application, leveraging a powerful tool that is offered in the Azure AI Studio, this prompt flow. We will see it in details. And then we will explore in details each core component of a flow that you can build within prompt flow, exploring also how to monitor your flow once it is deployed and how to consume it within your applications. So having said that, I will hand over to Mary Jo for the introduction.
Thanks. If you can go to the next slide. Perfect. Thank you. Right. So I think, a lot of has already been said. So whenever we talk about large language models, if you were there for yesterday's session, for example, we can talk about foundation models or foundational models that can then generate some kind of text. But the true power, of course, lies in their application. So you want to use those models for a specific application, for a specific use case, whether that's through a chat interaction, or what we're going to see today is going to be some entity recognition. So there's different use cases, natural language processing use cases that you can use these models for. To build those applications, so like imagine it like this: if you want to create like a whole pipeline that consumes one of those models, but also does other things to really take an input, use a model to generate something, and eventually give back an output to a user, you can use prompt flow. And prompt flow is, I would say, a feature, and it's available through different studios or different user interfaces. One of them is Azure Machine Learning. So Azure Machine Learning is a workspace that you can create, and through that studio, through the UI of the Azure Machine Learning workspace, you can use prompt flow. And this would normally be recommended if you're already working with Azure Machine Learning, if you're using it to already train and manage your own models, for example. But you can also use it in the Azure AI Studio. And we're going to focus on the Azure AI Studio today because that's in preview. And so we want to show the power of the AI Studio. And I would say like the AI Studio is kind of where everything comes together if you really want to manage your models for AI applications. So think then about like all the OpenAI models, the foundation models. If you want to fine tune one of those foundation models, you can do that in the AI Studio. And I would say like the user interface is a bit easier maybe than the studio. They're very similar. We're going to see as well that the concepts are the same. The underlying technology is also the same. But like I said, in the exercise in the Learn module, we focus on Azure Machine Learning Studio. So you already have it there. That's also what you can do yourself. But today in the demos, we'll focus a bit more on the AI Studio to show you the other side of things as well. Great. So let's go into understanding the development lifecycle of an LLM app or a language app. And first, I want to give you a bit of an overview. So if we're talking about the development lifecycle, I'm really talking about, okay, you have decided together with your colleagues or by yourself that you want to create one of those applications. Where do you start and how do you work? So this is really kind of the operational side of things. And the very first thing, of course, number one, is that you need to initialize it. And initializing mostly means that you really need to define the use case and kind of design the solution. So think about all the components that are necessary to create that solution. I think similar to whenever you would work with any other AI model, you need to think about what is the problem that you're solving. And in this case, since we're working with language models, we also really need to understand the objective. And with that objective comes a sample data set. So for example, if we want to classify news articles, that means our input, the input that we will get in production will be news articles. So we can then create a small sample of news articles that will be similar to the data that we're expecting in production as well. In this phase, we can also build a basic prompt, meaning that you will kind of instruct the language model how to behave. And then because of that information, you can also already design the flow. So think about it as the pipeline of what you want to do with incoming data, what you need to do with it, how you need to process it, and how you're then going to maybe clean up whatever output comes from a language model to give it back to the user. Then we have the experimentation phase, so number two. And this is where you really try and develop your first flow, but it's recommended that you do this with a small data set because, as per usual, um, you know, whenever we're working with models, it's going to be iterative. So you're going to try something, you're going to see what the result is. You're probably going to go back and edit your flow, edit your solution, then again evaluate and see if it is performing as expected. And here we recommend to work with a small data set, mostly because it will be quicker to iterate over and probably also cheaper to iterate over, because then you don't have to wait and then you don't have to use as much compute as necessary. Then number three will be the evaluation and refinement. So this is where then your larger data set comes in. So again, based on what you think how it will be used in production, you then create a larger sample so that you really test whether it works as expected, even on a larger data set or a more diverse data set, for example. And it could be that during this evaluation, where you might also use some kind of evaluation metrics, that you need to go back to your previous phase and experiment and edit your flow again. And here again, it's recommended that if you want to edit something, if you're going to edit the flow, that you first test on a small data set before you move on to the larger data set. And again, is really just to be more agile, I would say, with experimenting. And finally, when you're ready, you can bring your model to production, or bring your application to production is actually the right way to say this. And we're going to see this as well, because the way that you do this is by deploying the flow, and then of course you can monitor it to see if it works as expected. And that also again means that it might, like when you have deployed it, when you have integrated it into some kind of application, when people are actually using it, it could always be that there's something that you learn from it, and then you need to go back into, for example, experimentation to change your flow, edit it, evaluate it again, and then again push the newer application or newer model, for example, to production. So if we drill down a little bit, we can see how it looks like for each of these phases. So you can see initialization, we have those 4 steps where it's really about defining the objective, collecting the sample data, building a basic prompt, and building that flow or designing that flow. Because then after we've designed the flow, we would go into the Azure AI Studio, for example, and try an experiment. So we would build that flow, we would evaluate it with a small data set, see how it performs, look at the output, and iteratively go through that. As soon as we think it's ready for the next step, we go into the evaluation and refinement, where we test it with a larger data set, and finally you would bring it to production, meaning you would deploy your app, integrate it, monitor it, and then potentially again go back to experimentation if necessary. So as an end product, what it could look like, we have a little video for you here. This is in the studio. We're going to show this multiple times, but this is just to show you what the end product would look like. So on the right-hand side, you see that there's a graph, that's the flow. where you have an input, you have, in this case, 2 nodes, and then you would have an output. And then you can see that we basically have a complete application that uses a language model as part of that application. So remember, that's also why we're talking about language model applications and not necessarily just deploying the model itself, because the model is being consumed in some way. And we're going to show you today how to create one of these standard flows. This is a pretty simple flow, but you can add many nodes, and we're going to talk about what nodes are. We're going to talk about how to use your inputs and outputs. But just so you know, this is kind of what it looks like. And then as an output, you would have whatever you need.
Okay, cool. So we had an overview of what a flow might look like. Let's now dive a bit deeper into which are the components of a flow. So a flow basically is a graphical representation of the backend logic behind your LLM-powered application. And it's made basically of 3 main areas of components: input, output, and internal nodes. What are the nodes? Nodes are basically the components that feature a specific flow. Those components can be defined as tools. What are tools? Tools are nothing but elements that large language models can actually leverage while executing users' input. That, by the way, might be a query in natural language, as LLM suggested over the last months. The output, of course, will be determined both by the kind of task that we are pursuing. We will also see that it depends on the kind of flow, standard versus chat versus evaluation. We will see it later on. But it also depends on whether we decide to format the output in a specific format via Python tool. So let's now dive a bit deeper into the intermediate tools. There are 3 main tools that can be exploited and that there are built in within the prompt flow user interface. The first one is the LLM tool. We said that we need an LLM in order to have an LLM-powered application. The LLM tool basically allow you to put an LLM within your flow. It might be an Azure OpenAI model, or it might be another foundation model available within the Azure AI model catalog that, as Mary-Jo said, is full of wonderful LLMs that are mainly open source and can be tested and tried directly from the portal or deployed by a managed endpoint. Then we have the prompt tool. So the prompt is one of the main components within an LLM-powered application. It basically refers to the core instructions in natural language that we provide the model in order for it to behave like we want. So we can ask the model, behave as or act as an expert within a specific subject. Say just ABC to the user. Don't answer if you don't know the answer. So similar instructions. And this is important for 2 main reasons. First of all, because we want our application to behave and to have the style that we desire. And second, we can also include many responsible AI-related features and safety features within the prompt. For example, specifying the model, or better, prompting the model not to respond if it doesn't know the answer. It's preventing hallucination. And this is something that is extremely useful if we want to comply, let's say, with responsible AI best practice while in production. So the prompt tool is nothing but a box where you can write your natural language instructions, and it follows a specific format that help including parameters and variables within the prompt itself, so that it can also be fed with variables that come from previous nodes and can output variables that can feed the following nodes. Finally, we have the Python tool. The Python tool basically incorporates a full code experience within a no-code experience, that is the prompt flow. Python tools are basically small notebooks that can be included within your flow and can do stuff. They could format the output in a specific format. They could include some logic that is hard-coded so that you can add some determinism within your flow. Because remember that when we talk about LLMs, of course, we are talking about stochastic outputs. So maybe we might want some passages, some steps to be performed via traditional functions. So we can type them in Python and include them as hard-coded blocks within the flow. Now, these are the 3 main tools, but be aware that you can always create your custom tool. You can directly read it in the documentation, but we also provide a short video later on where we can see how to actually create custom tools. Now, we talked about different type of flows. What does it mean? It means that for your convenience, when initializing a flow, you can decide among three main categories: a standard flow, a chat flow, and an evaluation flow. A standard flow refers to, as the name suggests, standard flows, meaning that we are not aiming at a conversational experience, but rather are single tasks. For example, a Q&A application can be seen as a standard flow. For example, if you just want to query your documents one shot without having a conversation about that, without having memory is the key component that differs between the standard flow and the chat flow. Well, in that case, the standard flow might be suitable for you. Or as the example that we saw at the beginning, and we will keep seeing throughout the presentation, in case you want to specialize your application on a specific task, for example, name identity recognition, in that case, a standard flow is more suitable because you can really prompt it to be extremely vertical and specialized on a specific task like name identity recognition. So when to use a chat flow? When you want to have a chatbot experience. In that case, well, of course, we will have models that are more suitable for chatting, like the GPT 3.5 or 4, rather than completions model like DaVinci. Even though DaVinci is deprecated, there are plenty of the so-called base models that are mainly prompt to completion rather than chat interaction. So you will have chat models, and also you will have memory. When we chat with Copilot or Copilot for Edge or ChatGPT, we know that the model, the application is keeping trace of our previous interactions so that we don't have to repeat each time what we are talking about. Well, to do so, we have to store our conversation somewhere. And there is a whole science behind how to optimize the memory retention, the short-term memory retention in a conversation. So you want to embed these considerations within your application, and the chat flows make it easier for you. Last but not least, evaluation flow. The evaluation flow is peculiar in the sense that it's made in order to evaluate other flows, the previous two kind of flows. So we build a flow to evaluate another flow. The nice thing about that, but we will see it later on, so I will just spoiler a bit. The nice thing is that evaluation flows can also be created automatically directly by pressing a button saying evaluate my flow. Because in the backend, Prompt Flow will create the evaluation flow for you and apply it on your flow that you want to evaluate. That might be either standard or chat flow.
Yeah. And to add to that, these flows are really just templates that you can use. There's also many more templates that you can find in a GitHub repo that we have about Azure ML samples. But just so you know, like, because if you choose one of those templates, you can still customize it to whatever you need. You can still use whatever model that you've deployed within the studio. So don't worry too much about choosing the right flow at the right time, because if you need it, then you can still basically customize it to whatever use case you have.
Exactly. And that's the nice thing of Prompt Flow. And it's easier to be customized, but also offers templates to start from.
Yes, exactly. Yeah.
So let's talk about connections. Prompt Flow is amazing, but without connections, it's not really useful. So we need some APIs, just to give you the proper name, in order to communicate with external systems. So, for example, if you want to leverage the Azure OpenAI models, you might want to connect your flow to the API and endpoint that is your Azure OpenAI instance. Now, there are some connections that are out of the box, built in, others that are not, but the good news is that you can always create a custom connection specifying key value pairs, and we will see it in a very short demo. So let's see this video. Here I'm within my AI project in Azure AI Studio, and I'm entering my workspace, and I'm seeing my connections. As you can see, I have plenty of connections, mainly with API key, and I can add further connections, many of which are built in. But I can also create a custom connection, as you can see here, specifying, again, the key value of the information that I want to provide. Once templatize our flow, we need some compute power to run it. Now, compute is sometimes hard to manage because you might have a virtual machine that you have to switch on or switch off. You might schedule it, but it's still something to be managed. The cool thing about PromptFlow is that it can run on a concept of serverless compute, meaning that you will have runtime. What is a runtime is a kind of containerized and abstract serverless compute that already provides all the necessary packages that are needed for a specific workflow. But you can always add some packages if they are not present, but if you need it for your customized flow. You can either rely on an automatic runtime, meaning that the system will pick the compute instance for you, deciding for the size in an automatic way, or you can directly deploy your backend compute so that you can choose it when running your flow. And we can see here that where there is written the automatic runtime, we are already initializing our flow in that sense. But we can also have backend compute instance. Why do we need them if we just said that we don't like compute instance? Because you might want to run very specific models or flows that might need customized infrastructure, for example, GPU-powered infrastructure. In that case, having, for example, a managed serverless endpoint might be not enough in order to support your heavy workflow, okay? So let me just pause, seeing if there are some questions. Okay, fantastic. So let's address the last question maybe in this section, because we are jumping into the variance and monitoring options. So the question is how I can build conditional flows in PromptFlow. Okay, so just to address the question, building conditional workflow is possible, is definitely possible with the same application logic that you would use in an Azure machine learning designer experience. So you will simply set some conditional loop, for example. It might be also a Python tool, and then you will decide whether to run a specific branch or not. But more interestingly is the variance possibility. So what are variants? Basically, when we run a flow, we might want to have different configurations of a tool or an entity, or generally speaking, a node within the flow. So you can decide either to create a flow for each configuration and then evaluate each flow, which means runtime, compute, and time, or you can create variants. Variants are nothing but copies of a component or a node within the flow that live within the same flow. Because probably when you want to test variants of a component, you don't want to change the whole flow, but just a component. So there is no need to build again the whole flow with that variant. So for example, let's say that you want to build an LLM-powered application that will assist legals in their activities. Well, you want to specialize your model in the legal taxonomy, but you are not sure whether to use the taxonomy. You are an expert lawyer, or you master the Constitution, or you want several shoes. So how can I test them? Well, I can have the three of them and then evaluate the flow in parallel, having these variants. Or I could decide to test different configurations of the same model. For example, we know that temperature is a pivotal parameter while configuring an LLM. Temperature determines the level of creativity and that feature an LLM. So we might want to test whether a more creative model is better suited for our scope. And to do so, we can change the configuration of the model. We can also change the model itself within the LLM tool and create it as multiple variants and test the one flow that we have, looping and iterating over the different configurations that we have for each component. And this is an example of how we can do that. So let's say that we can generate a new variant of a prompt, as we said before. Now, the nice thing about this variant for the prompt is that we can also ask the AI in the backend to generate that variant for us, because the AI Studio in the backend understands that we want to slightly change the prompt. So it will generate an alternative prompt for us that is suited for our goal. So as you can see here, we have now another kind of prompt, and also we can see it graphically within the flow on the right-hand side of the slide. And having these variants for us, again, means having the possibility to evaluate the overall flow just once, and then see the different results depending on the variant. Once we are happy with the variants, we can actually consume our flow as a managed endpoint. And the nice thing is that we can also consume this flow via Python script, for example, but we can also monitor it, seeing all the logs and also the kind of the amount of requests that is having during time. Now, this is for the monitoring, but what about the evaluation of the performance of your flow? Well, first of all, evaluating the output of an LLM is a rocket science, in the sense that there is no one metric fits all. There is no accuracy. There is no F1 or true negative. So over the last year, researchers and academics try to find a nice way to evaluate the output of a flow. And the best idea that came to our minds was using an LLM to evaluate other LLMs. That's the only way. So basically, what researchers developed was a set of, let's say, evaluation metrics that are AI assisted, meaning that they have in the backend another LLM that is very vertical on evaluating other LLMs. So you might wonder, why don't we use the same LLM that produced the output to evaluate itself? Why do we need another LLM? Well, the thing is, having an LLM doing several activities, including judging itself, might be counterproductive. Better having two or more LLMs with specific tasks so that they are not biased, because LLMs don't want to judge in a too critical way themselves. Okay, so they want to do well, so they will never tell you, oh, I made a mistake. So better having another LLM that is vertical and specialized to the evaluation. So the nice thing about prompt flow is that it comes with built-in evaluation metrics that are AI powered, meaning that there is an LLM in the backend that demonstrated great impact in real life scenarios and that are employed in production scenarios. So let's inspect them. The first one is called groundedness. What's that mean? Well, first of all, when we talk about grounding, we refer to the process of limiting the scope of an LLM over a set of documents that we provide the LLM with, the knowledge base, basically. M365 Copilot is grounded on the Microsoft Graph. Okay, so it will not answer you or outside this perimeter. Or if we build a retrieval augmented generation application, we can specify in the prompt answer only on the provided documents. And this is a grounding technique. So groundedness refers to how accurate is the response with respect to the provided documents. So how close is the response with respect to the documents that I provided and that I want the LLM to be specialized on, okay? Of course, this kind of evaluation makes sense whenever I have knowledge base, external knowledge base provided to the LLM. There are so many applications with LLMs that are not RAG-based, meaning that groundedness is not even necessary. For example, the basic flow that we saw at the beginning, the name identity recognition one, has no grounding because there is no documentation provided, so this metric does not have any meaning for it. But still, it's very useful for RAG-based applications. Then we have relevance, meaning that we assess how pertinent the LLM application's output is to the given input. So in this case, the comparison occurs between the input and the output at semantic level. We then have coherence, meaning that we want to evaluate the logical flow and readability of the LLM application's text. We have fluency, that's literally the concept that we refer to when we talk about natural language between human beings. So it's the grammatical and linguistic accuracy of the LLM application's output. How fluent is the output in natural language? And finally, we have the similarity that quantifies the contextual and semantic match between the LLM application's output and the ground truth. So again, this is something that is mainly useful whenever we have some provided external knowledge in order to be reliable as a metric. So there are two ways you can pick in order to evaluate your flow. We said at the beginning that there is a particular kind of flow that is called evaluation flow, meaning that as we build a chat flow or standard flow, we can also build a flow that is meant for evaluating other flows. And you can do so directly from the prompt flow user interface. You can create a flow. You will be asked which kind of flow you want to create, and you will pick evaluation flow, and you can create your flow. And this is option 2. So I started from option 2, but we also have option 1. And option 1 is easier because it lets you create your evaluation flow directly from the front end where you are actually developing your basic flow. So here there is a button in the upper right side that says evaluate. And from there, you can actually create your evaluation flow. So let's see in practice. We first of all give it a name. I will call it NER evaluation test. It stands for name identity recognition. I will then select the metrics I'm interested in that case, fluency, coherence, and GPT similarity. I will select my connection for the model. I will add test dataset because, of course, we need a ground truth in terms of test data to be against which we want to test our model. In this case, as we are doing name identity recognition, I provided a dataset with description of the job title and correct label of the job title. Because when we talk about name identity recognition, the idea is that of extracting those name identity that correspond to a specific description in natural language. So I add this data set. You will see that I already have a perfect match, so I don't have to specify the columns. But here I need to insert some details in terms of variable that I want to match with the evaluation process. I will specify the entity type saying job title. This is the name identity that I want to match. And I will select the variables directly from the test dataset that I uploaded. Here I will then specify to which kind of nodes correspond in the flow. And then I can start the process of evaluating. Once the process is completed, I can also see the results. And here, as you can see, all my metrics have been collected in a very nice dashboard that I can inspect. I can also see like why, for example, similarity is 5.8 and not 4.8 and not 5, because here there is a typo. So architects. In fact, the score was not the highest. It was 4 out of 5 because there is this typo. But for example, here, it really doesn't matter because it was able to detect the job title. It was just a matter of singular versus plural. So it really gives you all the details you might want in order to assess the performance of your LLM-powered applications. And again, this having this built-in evaluation flow is extremely useful because it automatically run. However, it doesn't mean that you cannot customize it once created, because you can also inspect it at the flow level. As you can see here, we have a huge flow with all the metrics, some of which are not enabled because we didn't select all metrics, just a few of them. And here you can really customize as much as you want. So even though you are not creating an evaluation flow from scratch, remember that an evaluation flow will always be created if you're going to evaluate your flow automatically with the built-in option. So you can start with the built-in option and then, in case, just extend the capabilities of the flow, of the evaluation flow in a very custom way. Okay, so this is extremely useful. Okay, so shall we pause and see whether there are some questions? I didn't see the chat for a while.
I think there are some questions that we can also answer when we go into the exercise.
Okay.
There's one question that maybe you have an answer to. It was, is it possible to have variants with other LLMs not supported by Azure with our own API keys?
You can actually create custom connections towards external system with API and endpoints.
Yeah, exactly. So I think as long as you indeed have APIs, then you should be able to call it from the prompt flow as well. It would work a little bit differently than just selecting the deployed model from the UI, of course, but it would still be possible.
Exactly.
And I think there was another question: is the ground truth based on data we provide? And that's, I think that was already answered, but I think that's a yes, right?
Yeah.
Great. Yeah, I think we can then move on to the exercise. So I
Yes.
can then take over and
Yes.
show the the exercise. Again, you can do this exercise. I think there was a link in the chat as well. So you can do this exercise yourself too. Like we said earlier, the exercise is based on Azure Machine Learning Studio because I think the majority would have access to that. We're going to show it in the Azure AI Studio just so that you see what it would look like from there as well. I will also show a couple of other things while we're at it. And if you have any questions or curious about something, just let me know and throw it in the chat. And just for awareness, the Azure AI Studio, it is in preview, as you may see here at the top of my shared screen, which also just means that we're fully developing. So that means that it might look differently tomorrow. There's new features being released every day. And it also might mean that my view is a little bit different than if you have access to the Azure AI Studio, you may have a different view because as they roll out features, not everyone may get them at the same time. Most importantly, what you see here is that we have 4 tabs at the top. We have our home, we have explore, we have build, and we have manage. And Valentina was already sharing some of these. So for example, in manage, we saw our computes, our connections. So here you can see that I already have a couple of resources available. And that's also whenever you want to work with the Azure AI Studio, you basically create a project that then falls into a hub. So you can have multiple projects for a hub, and these are also associated then with Azure resources. So that's then how it will land within your subscription, which is also where you would indicate which region you want the project to exist in. So for some people, that might be important to understand which region their application is running in. It might also influence what kind of compute is available to you sometimes, because sometimes also the available virtual machine sizes are depending on the region that you are trying to create them in. And by default, the compute will be created in the same region that your project lives in. So once we're in a project in the AI Studio, and again, like this is a slight difference actually from Azure Machine Learning Studio, but underlying technology is the same. The UI is just like a tad different. But here you can then see that I already have a couple of flows and deployments in my project. And on the left-hand side, we see that we have different tools. So we have a playground where we can very quickly test different models. We have the evaluation that Valentina was just talking about. We have prompt flow that we'll get into, but we can also fine-tune foundation models where you would add a bit of your own data to further train the model. It's a bit different than RAG, where you would add your data as a search database, essentially. And I can show an example of that at the end as well, where we have a prompt flow with the RAG as well. We then have our components, which is where you have optionally you can add data. So again, if you would, for example, create a prompt flow to use RAG, so to basically search through your own database to give the context for an answer, then you could do that by creating a data or adding a data set here. On that data set, you would then have an index. That's how it would be able to search through your data. And here you can also see that we have deployments. And that's like for the first step, that's often the most important one, because through deployments is how you have the quickest and easiest way to make sure you have a model that you can use. So again, you can see that I have a couple already available. These are actually the connections that Valentina was talking about, because you deploy a model and then automatically it connects to it. So whenever you in your prompt flow want to use a model and you need to use or connect to a model to generate some kind of output, you would be able to connect to one of your deployed models this way. So this, if I click here on create, I can say that I want to have a real-time endpoint, for example. And as you can see, there's a lot of different foundation models that I can choose from, not just Azure OpenAI ones, those are the top ones, but we also have Mistral, Llama, and Hugging Face models, for example, that you can choose from. So here we have the GPTs, we have, Da Vinci is deprecated, but here you could basically choose what kind of LLM you would want to integrate into your application. And it could be that in your application, you actually use multiple LLMs. You might have different LLMs for different purposes. So one might be for chat completion, another one might be for a different purpose. So you can deploy multiple. Let me just show you one example. If I here go for GPT-4, can just select it. You can get a little bit more information, model card, where you can, for example, see, what kind of data was it trained on. Also know that there's always more information in the model catalog, which also links to Hugging Face website, where you will find a model card for each of the models that are available. And then you can find out, for example, what training data it was trained on, and any limitations or biases that that model may have. Let's see if we then deploy it. There we go. Well, we can give the deployment a name. The deployment name is really for yourself, so making sure that you know what kind of model is deployed. So if you want to specify a specific version because that's important to you, or like what it was used for, you can specify that in deployment name. And here we'll reference it as GPT-4. So now we see if we go into our deployments, we can see that it's added, as you see here, to our deployed models. But you can see that I have other ones as well. So once we have a deployed model, we can go into the tab prompt flow. And then we can create a prompt flow. So this is also what we then do in the exercise. So we can create one. And this is also the view that Valentina shared earlier, where you can then essentially select which template you want to work with. I would say the most basic templates don't give a lot of extra information, or don't have a lot of extra filled in information, are the ones at the top where you can see the standard flow, the chat flow, or the evaluation flow. But we also have a lot of samples that you can choose from, and they just have a little bit more information. So they might have more nodes, they might have more like a more elaborate system message. It could be different things that they have added to those templates to just give you a better starting ground. But as I said, there's also samples that you can find on our GitHub repo, and you can just use whatever template you think is easiest for you to start with. So in our case, we're going to do named entity recognition. In other words, we're going to extract entities from a text. So extract keywords, for example, from a text. We don't need chat functionality for that, so we're just going to create a standard flow. You can see here that it then specifies the location and also the folder name. So the folder name, that will be the name of the folder. And again, give it a sensible name for you. But just so you know, this is actually creating a whole directory with a lot of different files. And this is really also for your, what we call it, where all your code will be stored. Because right now we're working through the UI, but there is underlying it, there's code that will be generated for you. So you can also very easily, migrate your project or use a project in a different, if you want to take it from an experiment environment to a production environment, it will be through this that you can do that. So when you look at the samples on GitHub, you can actually see the code that it will exist within such a folder. So here I'm just gonna give it a name and then say to create it. And it will create a flow for me. So remember, in the back end, there's actually code, but we will just see the nice interface to make it easy for us to work with it. Let me just close this menu here on the left. And my recommendation often is the first thing you do is make sure you select a runtime, because often you need a runtime to be able to use certain functionality in the UI as well. So you can just start the automatic runtime. Valentina was also talking about this. If you want to have your own custom runtime using your own customized compute instance, you can do that. But in this case, we're not doing anything very special, so we can just use the automatic one. Well, you see a couple of things here. On the right-hand side, we have our graph, our graphical representation of the flow. You can see that it has the input. The first node is LLM tool, which is called joke. The second node is a Python tool, which is called echo. And then we have our outputs. And on the left, we can then see each of these, I would say, nodes. We can see their actual contents. And that's also where we can customize their content. They interact with each other. So if I click, for example, here on joke, I would be redirected to that part of the flow. And as you can see on the left, it would then show me what I need to do to make sure that it's customized to my specific use case. So let's go through that. Starting with the inputs. So like I said, what we're doing in this case is that we're going to do entity recognition. And our inputs will be that we're going to have, and we'll say what kind of entity type we want to extract. And then we have the text, so the actual data that we want to extract it from. So those are the inputs that we expect. So the first name, we're going to change it here to entity type. It will be a string, and what we want to extract is the job title. Then we're going to add another expected input, which will be text. And in this case, it will be something like software engineer is working on a new update for the application. And this is just, I would say, like a default value. Whenever you would have your app ready and you would deploy it, then probably that value is what would come in as new incoming, brand new inputs. But here we just have, I would say, like a default value, so that whenever we want to test our flow, it has something to work with. The next step is our LLM node. In this case, it's called joke because the template just has a joke, but we're going to change this because we are going to do entity recognition. So named entity recognition LLM node to give it a nice name. And then we're going to connect to a deployed model. I'm going to select connection here and select the default Azure OpenAI, I would say group. And then here I can choose one of the deployments that I have in that group. And you see that I have the GPT-4 that I just created, but I also have, for example, GPT 3.5. So I can try out different deployments to experiment here. You can see also that there's a couple of parameters that you can specify. So like Valentina already mentioned, we have temperature here. You also have, for example, the maximum amount of tokens. This would be something that you can play around with if you want to, again, ensure that it's, for example, stays small, so not generating too many tokens, and also what the response format should be. So you often have the option between either a JSON object or a text. And the response will be the output. So whatever response you're going to have here mostly matters for what your next node will be and how you want that output to be interpreted by the next node. In our case, we're going to send it to a Python node, so I'll just do plain text for now. Then you can see in this case, when you use an LLM node, you have a prompt field. So in the prompt field, you're going to specify the system message as well as the user message. The system message, for those of you that are not familiar yet with system message, that's just the instructions that you give to an LLM. And that's not something that a user will be able to see. So here you can really specify whatever the application is supposed to do. So in this case, for example, we say our task is to find entities. If there are multiple entities, please return them all with comma separated. But you only should return the entity list and nothing else. So this is really where you kind of specify what kind of output you want and what kind of format and how you want it. Like Valentina said, it could also be that you want to have multiple variants of a prompt like this. In that case, what you would do is use that prompt node. And here at the top, you can see that you can just add a prompt node to your flow. Because then first you would create your prompt node with different variants of your prompts, and then you would send it to an LLM. So then you would actually, now it's kind of combined into one node, but if you want to have different variants, you kind of split it up and first have your different variants, and then in the next node, you would send it to your LLM. Or if you're using an external model, like someone in the chat was mentioning, it could be maybe that, through, I would say like a Python node, you would connect with your API, for example. In this case, our user message, we don't want to tell a joke. We want to actually extract the entities. So I'm going to say, we have an entity type. that is coming from the inputs, we have the text that's coming from the inputs, and our output should be the entities that are extracted. Once you have created your prompt like this, you can click on validate and parse input. It's going to look at your prompt. And then here at the bottom, you're going to see that it will then also look at the inputs and allow you to link them together. So from the inputs, from the flows inputs, it knows that there's two available inputs to you, which is the entity type and the text. That's what we defined above. And for each of these, you can then specify, which they're related to. So here you can see from the inputs, entity type is related to the entity type that we have here in the flow or in the prompt. And in here, the text from the inputs is related to the text content also here in the prompt. Once we have that, we can go into the next one. Again, give it a different name just to make it a bit clearer what it does, namely to clean our data, because we might not want to give like the raw output of an LLM back to the user of the application. So here we can just say, okay, we're going to change this code. We're going to clean up the data to make sure that the information that we actually return to a user doesn't have any unnecessary data, unnecessary tokens. Like, for example, if the output of an LLM often contains those slashes, so we want to remove that so that there's no characters in there that a user cannot do anything with. Again, we would validate and parse input, and we're going to see that then it understands that it expects a certain value. And here we're going to say that the output of the previous node will be the input for this node. And finally, we'll go to our outputs. If it isn't disappeared, here we go, our outputs. And this is where we're then going to say our output is going to be the extracted entities, I think I have it right. And here you can then say, okay, that will be the output of that Python node. So that's how we can then specify this. Once this is all ready, you can save it. And most importantly, we can run it. And when we run it, we're going to see that we're going to be able to view the outputs. And the outputs are actually based on that default input that I showed. So the software engineer, yada, yada. So let me see if I can just run it while it's still saving. And in the meantime, let me have a look at the chat. Let me see. Is there anything interesting from the chat, Valentina, that you think we could address here?
I think the last question, which node type should we use to make flows branches based on the user input? Like if we have an intent, then run branch A, otherwise run branch B.
Do you want to take that?
Yes. Well, basically, it's based on the way you set your variables within your tools. So you might decide to either use a prompt tool if you want to detect the intent variable that will become a variable as an output of LLM tool, but you can also set it in Python with a Python tool. So it's up to your preference. In the first case, you are working semantically, otherwise you're working with hard-coded functions that are more deterministic.
Yeah. Yeah, and I have like a RAG flow as an example as well ready, so I can show you that, where I think it is included there as well, where they say something along the lines of like, if you have enough information, then go through to this point, otherwise just give this specific answer. Yeah, but to finish this off, now that it has run, we can look at the output. So here you can then see we have our inputs entity type, that was the job title. We have the inputs text, that was the text, the default text that I added. And you can see that the extracted entities is then software engineer. So again, if I want to test a flow with different data, I could also just change that default value for the text, or I could just upload a test data set in an evaluation flow and then run this flow multiple times with different inputs, essentially, to be able to get a list of the outputs as well and kind of compare and see how they perform. Let me see. Yeah, let me go to that other flow maybe. Oh, wait, here. So this extra, but this is a flow that uses retrieval augmented generation. It is actually based on another Learn module that we also have, and I think the next Learn Live session might be about this too. But here you can see just like a little bit of a different approach to how a flow would be created. In this case, it's a chat flow. So like Valentina also mentioned, this uses the chat history. So it has that already included in the template. And then you can see here that it also then takes chat input. And of course, like the output will be the chat output. And the very first thing that is happening here, by the way, you can also already see in the graph that there's two lines happening. So you can see that there's, in this case, there is a condition. So in some cases, it will, if there is history, it will use the history. If there's no history, it doesn't use the history. But in this case, what it does is that it will take chat input. If there is a history, it will rephrase the question to a standalone question. So it kind of removes all irrelevant information, or just restate the original question. And again, you know, we can add additional information to the system or additional guidelines such as don't add more details than necessary. You can then see that in the next part, this is a lookup tool. So this is again a node, but it uses a different tool. So not an LLM, not a prompt, not a Python, but a lookup tool. And this connects with a search database. So whenever you would want to add your own data to ground your application, you would use a lookup tool to retrieve that contextual information, I would say. So in this case, what happens is that you have your question that is taken. So you have your original question that was the input. Then that modified query with history rephrased it to make sure that that was basically a good query to send to your search database. That query is then sent to your database. And here you can specify how you wanted to query your search database, your data. And then as output, you would have context coming from your database. So additional data that you would use whenever you then generate an answer. And here you can then see that we're using, first we're using a Python node to clean up that search data, that output. Then we're using prompt variants where we're specifying, okay, you know, using that context, if available, we're going to send a request to an LLM to answer the question. So it uses the original question, it uses the context if necessary, if available, and then using those different prompt variants, it will then send it to an LLM. So here you can see that the last one is the chat, which just basically uses the prompt text. So the output of one of those variants that was available. And finally, you would then, again, have an output where it would just be the chat, basically the output that would be sent to the chat. So whatever input, like you could specify, depending on the different templates, you know, you could specify what your inputs are, what kind of type of input you want to have, but similarly for the output. So I see a question, if you can use a prompt to output error codes, you can specify this. You can make, and again, it could be that maybe the output from the LLM directly wouldn't do this, but you could clean it up. So you could say like, oh, if the output is something along these lines, then, you know, put this as output where it's like error code. So you could have kind of like a dictionary of different things that you could do. And then that output could be sent to whatever application that you're using. Because again, once you have this, so let me see if I can go back to this one. Once you have a flow that you saved and you ran, then you can actually deploy it. And deploying it will mean that you're going to deploy an application to an endpoint. And that endpoint will basically be an API that you can integrate with your applications. So you can have your endpoint integrated with your application, and you can have multiple, so your end user application, and you can have multiple language flows, put it that way, that are deployed to that endpoint. So you can also switch between different deployments based on, for example, specific needs, or if you want to update a model, then you can make sure that end application keeps on running while you're updating the deployment or while you're improving the underlying architecture. And this is also where you can then specify things like VM size and how many instances are being used, and if you're going to collect telemetry data. So this is also where you would be able to influence the cost, and you would be able to influence how much data you're collecting to monitor your complete application. Valentina, do you have anything to add here or something you want to highlight?
Maybe just one thing, just because you mentioned before that in the backend, the prompt flow is actually creating a folder with all the code snippets. Maybe something worth mentioning is that in the upper right corner of the prompt flow, there is this nice button, this open project in Visual Studio Code, meaning that you can actually work within the YAML files that are the backend of what the prompt flow has created. So again, if you're more familiar with a full code experience and you want to integrate the prompt flow within your favorite development tool, you can do that in Visual Studio Code. And I think this is a very nice feature. So you should give it a try.
Yeah, perfect. Thank you.
And there's also a question from Damian. Can we define global variables to store the information that the user has provided previously? So you want to go for it?
Well, I would say my first instinct answer would be like if there's specific data, well, you have your history, so you can always say like given the history, extract specific information. If there's really data you want to persist over time, then it's probably something that you would need to send to a database because this is not a database. This is just a flow, like a pipeline. So if you really want to make sure that something is persisted over a longer period of time, I would say use an API call to a specific database, for example, Cosmos DB, and make sure the data is stored there and retrieved at a later moment. That would be my instinct. I don't know, Valentina, if you have a different.
If I'm not wrong, if you develop your flow within Visual Studio, you might want to create a virtual environment, for example, where to install the PF package, that is the prompt flow in the Python packages. And there from your terminal, you can just set the global variables as you would do for any project Python based. So, but it's more in the development side of it. I'm not sure that you can actually do that within the UI.
Yeah. And then I see a question whether a flow like this can run on a simple Azure container or does it need GPU-based containers? Actually, again, correct me if I'm wrong, Valentina, but whenever you deploy a flow, it would run indeed on like Azure container instances in the background. And remember, whenever we deploy the model, so the language model, then we also specify like how, you can specify like how you want it to be deployed. So that deployment is using GPUs, but the flow is just using Azure container instances. So hopefully that makes sense.
And also, if you are using Azure OpenAI models, they live like somewhere in Azure data centers. You really can't have the supercomputer in your home. So
yeah. Let's see. Is there a way to estimate usage, deployment, and costs? Again, it depends a little bit on like which parts you want to have the costs for. So if you're looking at the different deployments, if you're looking at, for example, deploying your complete application, your complete flow, like I showed, you have whenever you select to deploy, you can see what the VM size will be, and based on those VM size, you can make cost estimations. So it really depends on the sizing that you choose and the models that you choose and those kind of things. But based on that information, you should be able to make at least some kind of estimate, and you have control over how it would be configured as well. Yeah, I don't know. Like, do you have anything to add to that, Valentina?
not really. I think you covered everything.
Yeah.
I don't see any further questions in the chat. Maybe we could jump to the knowledge check.
Yeah, let's do that.
Okay. Do you want me to share the slide or?
Yeah, you go for the slide. Yeah.
Fantastic.
I'm just looking at the question that popped up just in the chat. The requirement of having GPU-based containers puts AI out of reach for a lot of folks that want to try things out. I will say, yeah, that's currently that is a bit of a what do you call it? A challenge for a lot of people. Similar to, I think Azure OpenAI models are only available to people that have, I want to almost say like a organizational subscription. I don't think it's available to personal subscriptions yet. But yeah, that's currently the state of it, how it is. But if you do have access through your organization, then at least you have some things that you can play around with. But you also have to realize, from any provider side, GPUs are quite expensive. So it's also that we're trying to protect and make sure that not everyone is just going crazy and using all the GPUs available, because it's not very sustainable either.
So true.
Yeah.
Okay. So I think that you can scan the QR code if you want to join us in the knowledge check, and you can also vote your answer in the link that colleagues are sharing in the chat. We will also have a live polls to see live results, and we will also have like the next slide pointer showing us the correct answer, so we don't risk to miss any correct answer. Okay, let's see whether someone is already voting. Don't be shy. Someone in the chat is saying B. Oh, B, by the way, is the correct answer. Anytime someone doesn't know the answer, say B. It's like the default. default. Okay, I think that the poll is not having success, but someone in the chat is interacting. So let's say B. Okay, let's go. And the correct answer is B, as suggested.
Very good. Yeah, just
So
only
is an
me from now on.
always B. To generate text, what do you need to create to ensure prompt flow can surely kill the deployed? Of course, you need a connection, because we said that in order to leverage a model that is a third-party system, you need to connect your flow to that third party. In case of Azure OpenAI, it's nice because the integration is built in, so you don't have to customize your connection. Great job. Next one. So you want to integrate your flow with an online website. What do you do? What do you need to do it easily integrate your flow? Someone is saying C.
Just as a side note, I see the questions in the chat, and after the knowledge check questions, we can circle back to those. So don't worry, we're not forgetting.
Okay. I'm reading the chat as well. Fantastic. C. Okay. Okay. Shall we go for the final answer?
Yeah.
Deploy your flow to an endpoint. Yes.
Very good.
Correct.
I mean, it could be that you need a custom environment, but it's not necessarily, that's not a need to be able to deploy your flow and integrate it with a website or an end user application, essentially.
Yes, exactly. And the managed endpoint is also like a very nice containerized solution with embedded monitoring features that you can leverage in order to monitor your production application. So definitely the endpoint is the final answer. I think this is the last one. After deployment, you notice that your flow is underperforming. Which stage in development lifecycle should you revert back to? Okay, I wouldn't know this one. So I'm happy that we have a review of the answer. Okay.
It's also going back to an hour ago when I talked about this.
Yes, exactly.
So much has happened since then.
Someone is saying A, experimentation. Someone very specific, experiment with small data sets.
Very good. Someone
This
remembered.
was a bonus. We don't have any gadget, but
definitely
you
bonus
wanted-
points.
Okay, let's see it. Experimentation. Correct.
Yeah. And I see the answer is B, and it sort of like makes sense in a way, but what we're saying is kind of go back whenever you want to edit a flow, go back to your experimentation to make sure that you can first test it out with a small data set before you would go into B, where you test it with a bigger data set. At the end of the day, it's also like up to you. I mean, these are just guidelines, but it's really just to give you some kind of idea of like what would be a good practice to do it. I think that was the last question.
Yep, it is.
So
So,
just before we wrap up, just quickly going to answer, I think, one more question that I had about the search database. Again, I would recommend going to the retrieval augmented generation session. I don't know if we have the overview of the next session somewhere. But basically, how it works is that, especially that lookup tool that I showed you, it will automatically or easily connect to Azure AI Search. That's like a built-in connection. But if you want to connect to some other search database that you have, it would also be possible as long as you have like the API connection available. Like Valentina showed earlier, connections are always possible if you have like custom keys to an API that you want to connect with. But the default is just Azure AI Search.
exactly.
Awesome. I think hopefully that
Yeah,
answered all the questions.
I think so. I see a lot of letters, capital letters, but I think that are answers. So, no, I think no further questions. Okay, I think we can wrap up. Well, we covered basically the end-to-end life cycle of developing an LLM-powered applications, and more specifically, we did that using a very nice user interface, low code, but can be actually integrated with full code experience. That is Promptflow, and we encourage you to give it a try. Personally, I think it's a very nice tool because, again, it makes it really easier to start developing your backend logic within your LLM applications. And if you want to go through the learning module once again, you can scan here the QR code that points to the module that we covered today. And don't miss the upcoming sessions that will be delivered starting from tomorrow. And again, if you want to rewatch the previous sessions, you can do so again, scanning the QR code here. And finally, you can join us on the Discord community and interact in many conversations like this one.
Perfect. Yeah. Thanks, everyone. Yeah. So look at the Learn modules, look at the GitHub samples that are available. And if you have any questions, feel free to reach out to us online. And hopefully this is valuable to you and you feel confident to explore more.
Fantastic. Thanks to Mary Jo and our moderator. And see you next time.
Bye.
Bye. Bye-bye.